All right, we should be streaming now. Let me check my phone. Channel. How's the audio? All right, I think we have audio. I'll turn off my speakers to be safe. All right, feed is still going. Pop out chat. Okay. Try this again. All right, let's see what happens. Get a couple more viewers. I will start the show. Let's see. Looks like we got some more viewers. All right, if anybody is watching live, could you tell me how the audio is? I don't really have a way to check. Just hop in the chat and just holler. And yeah, how's the audio? How's the camera? I'm trying a new audio setup. I got my lapel mic back. Turns out these lapel mics have little tiny SR44 cells, and it was completely dead. So I put fresh batteries in. And I'm also trying to use the built-in audio driver software to boost my mic volume as well as do some noise suppression. So if anybody who's online can just say yay or nay on the audio quality, that would be awesome. Well, try one more time on my feed. I really hope I don't get a crazy loop back, but we'll break through it, huh? That's not right. Great. Hello. There's a annoying delay between stream and my machine. Hello. There's a annoying delay between stream and my machine. All right, that sounds pretty good. I'm just gonna get going. Hopefully, anyone jumps in will let me know if things go sideways, as they're bound to do. Just getting my computer layout away so I can see the chat and audio levels. Well, I'm gonna be talking like this, so I think we'll be right in the perfect zone. Well, anyway, thanks for tuning in if you're watching this live or if you're watching the recording later. I built a 3D printer a long time ago, and I used a kit. It was the Duplicator i3. Great machine. From the moment I got it until I took it apart, I was constantly upgrading it with new parts and 3D printed enhancements, and I decided to build upon it, kind of partially new, with a new frame, sturdier frame. The project was called the ReDuplicator. It's on GitHub. The creator of it put together a really nice, detailed wiki. Some things are have typos or improvements that didn't make its way into the wiki, and so I fumbled along the way. I got through about half of it last year, and then things happened. So I'm trying to motivate myself by doing this live stream to get as far along as I possibly can. Because honestly, not having a 3D printer and being home all day is kind of a drag. So what the goal here is just to churn through the wiki. In the previous live stream from last week, I talked about how some of the parts, they kind of cracked. And while trying to disassemble them so that I could clean up some of the drill holes and whatnot, cracked even further. So we re-glued them, and then we really didn't get very far. So hopefully today we'll get to some milestone. The wiki is broken up in sections. We are on section end of section 6, the x-axis, the x-axis gantry, I should say, so that we can put it onto the frame, which we'll get out momentarily, and then move on from there. So back to hardware. Let me switch cameras. If I can remember my settings, there we go. Get some more light over here. I'll dim this background light now that we don't need it so much. Now that looks good. So if you recall from last time, we have the two halves of our X gantry, the hot end, and the X gantry smooth rods. And it's going to kind of look like this, but not exactly, because this photo was taken. Clearly says the extruder is pointing in the wrong direction here. It should be pointing the other way. Do the opposite of this. There's actually a couple different designs since this was posted, but needless to say, it should be something like this, and this, and this. All right? So what we got to do, now that we remove the original rods, is put the rods in place. This was the issue. I didn't drill out the holes originally with that 10 mil drill bit. I don't know if you can see it, but there's actually a little stopper. There's a couple of variations to the design, some iterations that I'm not going to did, but anyway, there's a stopper on one, and I accidentally drilled all the way through. Yeah, that's not supposed to be there. But it should still fit. I did some test fits. And so before, I was shoving this in, which caused the original cracks. And now it can go in and out fairly smoothly. There's just a little bit of give. And we do have this set screw that will hopefully keep it in place, at least until I print new X gantry holders. So if I recall correctly, I need a long ruler to help with some spacing. Yeah, we'll use this one. Things falling in the meantime. In the original video, I used this as the guide. And I think, let's go back to the beginning. Insert two of the rods. Insert two of the rods into X motor mount. That's this fellow. In the roughly 15 millimeters, just so these are 32, what does it say? 320 millimeter rods. Cool. And so, 15 millimeters would be around there. I'm just bad with math, so I try to cheat whenever I can and use tools to my advantage. Oh yeah, that's so much better. So we said 15 millimeters is 322, right around there. Okay, and yeah, about spot on. Let's look at the other one, and they are equal in length. And let me get my little right angle here. I think this is going to be a little bit more of a push, or it just doesn't like it. Not a problem. We'll take care of that. We'll take care of the difference. Let me actually assemble this. But approximate is good enough. Okay. Tapstick idler, which I already did. Have extruder pointing from the flat side of the gantry parts. So that would be like so. Have the extruder pointing forward from the flat side. These are the flat side. And then last time I did put some grease, lubrication, actually some pretty nice lubrication, but I will reassemble it before we do it again. You can't have too much synthetic grease. But just for a dry fit, let's get that in there. And this other piece, again, just so if we look at that photo, I don't want to put too much pressure on the tiny hot end. As a reference, this is right. Let's see the wrong way around. So this looks good to me. I will remove this ever so gently. Oh, I heard a crack. Ah. I went for the name brand grease. I'm not trying to save money here, and this was not very expensive. The problem is I don't have any better tool for application. So it's kind of like, all right, kind of just, I don't know, move it there. So I think I'm going to use just a flat screwdriver and kind of just put it in there. That seems like a better idea. I have absolutely no idea how much I should be putting in here. So what we'll do is put a little more. Can't hurt. Kind of get it further in there so it spreads around better. Remember, this gantry is going back and forth in both directions. So I want to make sure we do that right. So we want the hot end pointing forward from the flat end. It goes like this. And then like this. And as a reference, we'll see. I'll flip this around. So you can't see from this image, but if I'm going to guess, this is where the motor mount is supposed to be, which is cool. We need to space this. We need to space this 287 millimeters between the two mounts, which is hard to eyeball. It says the spacing of the Z-rod holes should be exactly 357 millimeters. So that's why I have this tape. From outside edge to outside edge. That doesn't seem right. Oh, what a goober. It says the Z-rod holes. Z-rods, not the threaded rods. So that's about from outside here. I think we need to close it up a little bit more, but let's double check. This should be from here to here. Right now it's about 294 millimeters, and we're supposed to be 287. So I think I need to push this in. Okay. Double check that. So now we're at 285. It's a little bit tight, so I can go and pull that out. Just a little bit. Because what's going to happen is if this is too close, as the X gantry goes down, it's going to start to bend in, and that's how you validate that you've got the spacing correct. Because I really don't care about the outside dimensions. I care about the inner ones in this test. I think there's going to be a lot of trial and error here. Yeah, so we're at 290. So I'm going to try to just very gently push it. Pretty much bang on. Maybe 288. I don't know. Let's start with that. We're going to call this the test. And remember, nothing is locked in place with the threaded nuts here. I have super lube everywhere. It really is. No false advertising there. So I have everything there. Let me just check the live stream before we bring in the base. Trying to see how many viewers we have. Ooh, nice couple people. Welcome. Let me just look over Twitter to see if I'm missing any people yelling at me. Not because of something I did, but maybe because the live stream is busted. Okay, we're all good on streaming. Let's go back to OBS. All right. So the next phase is putting the motor mounts on using 2030. Install the motor mounts. He used neoprene washers. Yeah, I don't have neoprene washers, only these hard plastic ones. I'm going to pretend that they are good enough. So we have the screws from last time already there. I will take interesting. It doesn't say which direction the motor should be mounted. Install the motor on the opposite side, flat side. Alternatively, mount the motor on the flat side to avoid this. Why would you do that? Ah, whatever. Let's assume that it goes like this. Might not have long enough screws to be fair, to be sure. Okay, let's see what other tools I have in my toolbox. From all the parts. Head socket screws. And I'll just grab something. I have M3. Yeah, I just use 3M3. M4. That's not what I wanted. M5. I bought this variety pack from the internets. I feel like there was an M3 in here. Well, this will do, no problem. Again, it's just trying to create a little bit dampening. Sorry for the weird angle. See a few threads. Okay. And you can't see from your angle, unfortunately, but there's, I'll show in a minute. There's slots cut out here. You can see that the motor moves a little bit. And that's for tensioning. That's straight from the Prusa design. I don't know where they got it from, but it's a good design. All right, we are moving forward. We have approximately the right width. We have our motor mounted, and don't tighten the motor yet. This can be slid onto the printer tower. All right, move this out of the way temporarily. And bring back the printer tower. This is gonna be an awful, awful shot. It's actually not enough space to work with. I'm gonna switch over to the front-facing camera to see if that is more helpful. So you can see the printer tower. This is the front. Sorry, this is the front. I'm going to install this backwards. Just, I don't know. I need a deeper desk. Yeah, there's a few loose ends here. Let's see if I can get my longer Allen wrenches on my messy underdesk. Where should they be? All right, not there. And maybe here. We'll move this aside for now and try to find my Allen wrenches in a few minutes. I don't find them right away. Okay, we're moving on. This probably got a little loose. Not too bad. Everything else is nice and very rigid. Oh, right here. So it's as it is. Well, once we have everything in place, the top will keep things even more rigid, which is cool. So what I'm going to do is lubricate the Z as well. Switch to overhead. Get my official lubricating tool. Put a little bit in. These are actually pretty shitty linear bearings. Not that the original ones were any better, but I've lost a few ball bearings in the manufacturing process, assembly process. Okay. So now back to the front-facing camera. Okay. So this is the front. This is the way. Actually, it should be this way. And what I want to do is move things here, put the hot end the other way around. Yep, just so we can get a better shot. Oop. The extra lubricant. I can easily put that here. So now the threaded nuts are sitting nicely on top. It doesn't matter that these aren't exactly the right height, but what I need to do is bring this down to the bottom. Manually, it says, slide the gantry onto the smooth rods and then rotate the lead screw in unison. Run the gantry up and down, the axis all the way. If the Z-axis bends as you go, it means the gantry distance is misaligned, adjusting them as necessary. Yeah, I'm not a robot here, folks. It's hard to tell if it's misaligned. I really think it needs to be at the bottom. If I were to. This one looks, the distance, let's see. I don't know if you can see from there, but the distance between the edge and edge is, I don't know, maybe use real standards here. 2.6 centimeters, and then from here, it's 2.4. I think this is still too wide, but let's get to the bottom of, for me it's really hard to tell. It's given different, yeah. Getting tighter and tighter. Let's check the distance to the very top. That's 2.7. Let's see. 2.5. 2.5. 2.4. What is it saying? Adjust the Z rods and lead screws bend as you go. It means the gantry is misaligned. Adjust as necessary. I mean, how am I supposed to know, guys? Everyone. We're at, what was the original interior distance? 200 and, this corresponds to 287 between the X gantry idler and the X gantry motor mount. And that's this distance. And we are at, trying to make this as accurate as possible, 284. Okay. Let me just, yeah, it's kind of hard to measure the bottom distance with the hot end in the way. Let's, of course you can't see. Let's try to switch the camera to, let's be in frame at all. Kind of. All right, let's slide into, yeah, this won't work with the gantry there. Wish I had some measuring calipers or something like that. Because I don't know if the top and bottom are the same. Yeah, there's no way for me to measure this reliably. So, just to show you what I was saying earlier, this oh, I have an idea. Let me, let's going to use some other technique. Aha! If you know anything about me, I have a favorite saying. You can't have too many clamps. Why does that matter? I'm going to try to use the clamps as a guide mark for the spacing. This clamp might be too big. Oh. Here's what we're going to do. Get this all the way back up. This is what I hate about manually moving 3D printer components around. There. It's coming for you. I can adjust this a little bit, right? Like for long-term use, your hands get tired. I just want to do one at a time. Free. Okay. What I want to do, I'll move the gantry frame out of the way for a minute. Is flip this. If you missed the last video, talk about this neat trick that some clamps allow you to pull off the end, slide it to the other side, and now you have outward clamps. It's very handy when you need to keep something apart. Or, in my very non-traditional use case, use it as a distance guide, measuring aid. To do this, line this up. There's a term for this type of measuring tool. I just can't think of it right now. So, measuring from outside to outside, we are at 287. I think this self-corrected, if I were to make a hypothesis. Looks just about spot on. Friends, we may be ready to move to the next phase. In the meantime, I'm going to put a little bit more of our lubrication on the threaded rod side. I'm going to keep this out for, just keep it in the corner for a minute. Bring back bring back the frame. I hope I assemble this correctly. Which is to say the hot end should be facing towards the pulley. Yep. You've already seen this part, so it's not super interesting. And I'm just gonna run a little bit. A little lubricant at the bottom, kind of to spread it. That's a funny sound. I mean, the carriage will thin most of the time at the bottom, so I figured that is where we can put the most amount. And as it goes up and down, it will redistribute it. Probably lubricate it again. You don't need a whole lot. Actually, too much just kind of splatters everywhere. Gunks up the system. Now, this is name brand Super Lube. Whatever was shipped with the original one, how was not a name brand of any brand name. Take some of the excess here, very top. Probably be redistributing this every so often. Get this back to the bottom. Do I have a little level? Do have a little level. So you can see kind of just tiny little mounting level. We'll use that to try to stay true to being level. That's cool. I just realized where I put most of the lubricant will never touch the threaded rod, the threaded nut. Cool, John. It's literally gonna just kind of stop right there, which leaves about I don't know, five centimeters. Come on, use your head. Get some chin wipes and just kind of soak up the excess. Now you learn. A little How about this technique? Okay. I'll use this to grab. Now this is too greasy. Fantastic. Okay. So when you're sure about the aligned, and when you're sure it is aligned, screw 4 8mm countersunk screws into the heat inserts to secure the spacing. Those are these. 1, 2, 3, 4. Let's try to find some right-sized countersunk. What? Oh, aha! I have these. Let's find the right length. Oh, they seem good, like as good as any. That's a nice crunch. This design, there's been improvements since I made it, since I printed the original parts. It's going to be hard to figure out what's different. But for example, it uses threaded inserts, which I installed in an earlier video for most of these pieces. But then it also uses these countersunk screws often. And I'm just curious about it. Irks me a little bit that it sticks out. I would probably use cap screws, but maybe those are not as readily available in these lengths. Just to get a nice flush piece, but maybe the countersinking helps with it. I don't know. Well, I can happily say that we're done with section 6. Well, that is a major improvement in progress. And let's catch up with the rest of our documentation, shall we? So there's the bomb. I had this neatly organized last week, but failed to keep it organized for today. That's what we just did. 6, 9, 8, 7. Okay. Home 1, 2, 3, 4, 5.1. I forgot there's some variation, which I skipped. So we can put these to the side and move on to 7. Complete the tower. All right, I'm going to switch over to that overhead so we can scan it together. I'll move that a little bit further back. All right, now the gantry is installed, the rest of the frame can be completed. Attach the final 380 millimeter crossbeam horizontally to the 355 millimeter tower parts. It's out of frame. On the front side, attach using 12 millimeter M5 screws into the tower corner bracket large, then the plate bracket. Also attach the 30s corner pieces. Okay. Then on the back side, where the rods are, use the Z-axis top left bracket and Z-axis rod top right bracket. Each of these require a heat insert. Ooh, we're going to do some heat inserts. Mount of these with 12 millimeter M5 screws while also securing this with the rod. So, vision of what that looks like. Use a 60 millimeter 3 and 3 screw into opposite side of the heat insert to secure the threaded rod. Okay. The printer should look similar to this. Ooh. Ah. That's cool. Install the M3NS nuts into the gantry and slightly install the 20 millimeter M3 screw and hold the top. Blah, blah, blah. Install the belt. Oh, this is going to start to look like a 3D printer. All right, let's try to get some level of organization and space made available. Okay, so the first thing we need go back to the front. The first thing we need is the crossbeam. So this is a nice anodized Misumi pre-cut beam that the rest of the frame's made out of. We need 12 millimeter M5 screws. Let's get some of our bag of screws. Which one is this one? M512, that's this. And then let's get the rest of our 3D printed parts out. So there's some nice organization in the guides, and I collected all the parts that go to a section. So this says complete the sea tower. So this should be everything we need to finish this. You'll see this piece, these top corner pieces look very similar to the bottom ones, but they don't have a cutout for the crossbeam. So that's how you knew from the beginning that they're needed. Then we should have, I'm going to guess, some T-nuts. Yep, some of our T-nuts. And I think last time I used some washers to fill in some gap. Well, we're going to need our belt. I'll just keep that to the side. And where are the plates? The metal plates. Aha! Again, I bought all the specialized hardware, so these metal plates, Mizumi cross beams, extruded aluminum, and the 20 by 20 reinforcing pieces. These, I can't see it because the lighting's awful, but it's you can 3D print these, totally 3D print these, but they're very inexpensive directly from Mizumi, so I thought, why not? And I want this to be a rigid frame. All right, let's switch back to the overhead. I keep on hitting the wrong button, but all right. So off out of frame, we have our crossbeam. On the front, use the corner bracket large. Attach the 3D crossbeam horizontally to the tower parts. I mean, that's just placing it here for now. Okay. On the front, so we're looking at the, so this is the front, right? This is cool. On the front, use the M512s. I'll probably need 6 of these, I guess. 8. So like so. Right. Again, it's very similar to the previous assembly steps. Let me remap these holes real quick. It doesn't have to be perfect. But last time, did not do any cleanup. That's always a bad idea. If you don't have one of these reamer tools, they're extremely inexpensive and they really help for assembly of these kind of things. Let's do a quick outside as well. Some of these holes came out very gross. Oh, it's because they have some weird overhang optimization. It'd be impossible to show you on camera, but needless to say, they're trying to be clever. Doesn't matter. Moving on. And what would that be more like? This? I don't have an electric screwdriver to help me this time. Cool. I'm using this to the first pass just to soften it up. This is very tedious. And in my YouTube video, I speed up through some of this stuff. I even just cut it out because, I mean, watching someone tighten a fastener is not exciting. It's also not exciting to do, but you gotta do it because otherwise this thing won't build itself. Do-do. It means you get some better hand screwdriver. A drill is just way too aggressive. Okay, so that should be a general sense of where this might go. Right? So they go in each corner, and the brackets are definitely deep enough. What we'll do is get our T-nuts out. I don't have enough experience with T-nuts, but I can tell you that I think they make a difference where you buy them from. The machining quality, even just within this random bag of, I don't know, eBay T-nuts, I've noticed differences. It's all good, but fortunately these are cheap, so if one doesn't work, I just put it back in the bag, then try the next one until I get a good fit. So I'm loosening it up just enough so I can get some teeth on the T-nuts. So you want something like, you can't really tell, but I kind of end up putting the button head just hovering over the flush with them 3 different apart. So there's enough room to the T-nut to slide around, get a good grab. See the texture that's on the T-nut is so it can kind of grab a little bit into the metal, which, like I said, makes it a little fiddly. But fortunately, we can play around with it. This is not a hard and fast setup. So what you kind of do is twist it until T-nut captures in place. I don't want to tighten them all up just yet because I want to yeah, I'm gonna, like I have to attach these corner brackets. I will so I need 4 more pieces, by the way. 4 more 12mm M5 screws, I should say. And while I'm here, get another 8 T-nuts out. 4. Nice. Let's go back to the overhead. Keep things as neat as I can, just because there's so much going on. Let's clean out one more of these. I don't know if you can see this as well, but this is basically a tiny blade. And because it spins freely, as you put it in there, it helps just carve out just the slightest amount of material. You maybe can barely see it from the camera. But next up, getting 4 more in here, and the boring tedium begins. You kind of don't have to go all the way. I like to, and I'll cheat, just because I did use the boring tool, whatever it's called. Spinny tool that helps open up holes. All right. By the way, what's our timestamp? How long have we been going for? Come on, computer. It's just a live stream. What does YouTube say? An hour. Oh boy. Also getting a little warm in my shop, aka our second bedroom. So I might have to take a break eventually, or kind of call it early. Get YouTube out of the way. All right, so this is the other corner. All right, cool. Put the bracket in. Nice. Yeah, fumbling around a little bit. Okay, let's get here. Okay, you should be able to just slide this in if you can align the T-nuts themselves. I might push this one. This screw didn't go in straight, but that's okay. Come on, little Tina. Okay. We are fixed. Let me just tighten this a little bit. Gravity, right? So we don't want it to come out. We just want to tighten the T-nuts enough to get some grab. Always loosen the T-nuts too, which is okay. All right, so basic brackets are in. Now I got to put these supports. This is going to make it that much more rigid. Do it carefully. Probably do it from the back side because I can reach through there a little bit more easily. My problem with this view, unfortunately, is you can't see what I'm doing. I'm really bad at camera work. I like to really appreciate just how tough it is to be a streamer. So hats off to you full-time people, or people who do it more than twice, like me. A little bit of contortion work here to get my hands through all the different pictures, but this piece might require a little spacer. You see that? Here's what I'm going to do. We're going to try a different camera angle because this is just not helpful. Let's see, does this help? Oh, there we go. This might be a better angle. Now let's try to raise the... Sorry if I'm in the way as well. But the idea is to get these pieces in like so. And I'm going to take this off. Get an under angle shot. So I want to make sure these are nicely and even. This piece is already locked in at the top. I'm going to go finger tight. Okay. Everything I can keep on readjusting as needed. Oh, cool. Let's see if we can. No. I'm just trying to shoot cameras. OBS is impressive software, I gotta be honest. I give credit where credit's due. You can do so much with free and open source tool that I don't even know how it would do otherwise. Does this help? Nope. We need light, as much light as we can get. So same thing. This piece fit in 2 screws. So now that they're lined in that way, you can tighten it. Cool. Oh, that's not good. Aha. Okay. So everything is roughly aligned. Let's see what does the instructions say to do next. All right, well, I'm just going to tighten everything. Go back to front facing. Oh, I just don't want you guys to be sick. So many cables, you have no idea right now. Okay, and we'll just tighten each one. Because these are not perfect prints, we'll have to probably go over them a few times to get them truly dialed in. I can keep on going for this one for quite a bit, because it's both the hole for the screw itself as well as where the button head sits, but they're generally okay. I'm actually not worried about cracking these pieces. Famous last word. See how that, yeah, it's moving? That should move at all. So there's something that's, I'm tightening too, that's not grabbing. Yeah. And this metal plate that we put underneath is helping with a lot of that sort of grab. And rigidity? Yeah. Nice. Get plastic. And that shouldn't be spinning so freely. There we go. It's pretty solid. It's wobbling that way. Ooh, there's a loose screw there. That's not a good sign. that won't impact the XY motion, unfortunately. I wonder what's causing this one side to be looser. Tighten the heck out of this. Well, let's keep going. Gotta tighten these pieces, then we'll be done with this part of the frame. Well, at least these two pieces. Fascinating. A little bit of a gap. See that? No gap there, gap there. I don't think it's just sitting right in the slot. Well, I'll try to fix it and then we'll see if that'll affect it. There you go. Cool. Now, what is going on here? This can't be done right. So this can move forward. That shouldn't be possible. Well, I'm gonna let that stop me. It's gotta be something Okay, now we turn this around. Turn this around, and we have these pieces. Something like this. Okay, so they need heat set inserts, which are always fun to do. So I have to figure out which side the heat set insert goes into. That's easy. It goes in there. Well, let's find the right heat set insert to use. And these. I have two sizes that I used. this project. I'm gonna guess it's those. Not very well marked, but easy way to test. I need 16mm M3s for this. Yeah, the bigger one. That's what I figured. Is that the length I want? Yeah. Let's grab two of these. Two of same size. Get this out of the way for now. So these should do something like so, for example, on this side, which is what they're showing this photo, should go like so. So how far in does it go? All right, let's get ready to do some heat inserting. So normal iron, plug it in. Bought these nice machine tips from Tindy. Make it a little bit easier. Get the step cut out for different size heat set inserts, so it makes nice and flush. Some people build a little jig that has nice mechanical motion, so it can easily be depressed like a drill press. I don't have that. I just have eyes. I eyeball it. So I'm going to get the heat insert in there, just deep enough to and straight enough to go to grab in and not poke out. So pick it up. This will be hot. Can't use. Let me get some tweezers. And hold this better and safer. I'll walk it over. Ooh. Okay. Let that cool. See if that's deep enough. Still warm. I'll get started on the next one. Once the fluid cools down, I will do a test, a dry test to see if it's deep enough. What we don't want to do is push this all the way through. That's the real fear. But we need it to be deep enough so both neurals, both sides of the neural, have enough material to grab into so it doesn't start to just turn around inside of the plastic. Okay, this is warm, but totally usable. Sticking out a little bit. I'm going to push it down just a smidge further because that's what I did with the other one. You can kind of rework this a few times. The plastic around it will melt and give you that extra bite you need, but you can't do it too many times because you might not have enough plastic left over. Let's see. Let's use this one. I haven't cleared this yet. See, there's a piece of paper, scrap paper. So, still a gap there. What I'm trying to do is just to hold on to the smooth rod. And once I clear that gap, then it goes into the other side of the hole. And hopefully it grabs a little bit onto the feather nut so we can tighten this nicely. I think I might want to use this side just to get a little bit more leverage. Whenever you do a heat insert, a little bit of the plastic flows in. I should have gone the other direction to there's still that gap, but now we have the screw there. The idea is that we'll be able to tighten that gap. Ooh, that was a cracking sound. Well, that's not good. I don't know why this plastic is so brittle. PTG. It's, I don't know. I'm gonna dab a little bit of hot glue here, just for extra protection. You know what? Yeah, definitely gonna get that out. I think we're good on heat for now. Turn off the iron. Back. The should have done is clear out the excess plastic that went into the heat insert first. There's not a lot of room for it to go anywhere, but at least it would have broken up. Oh boy. Did I push it out? Yep. Now I can see it was clear all the way through. Let's do that first on this side. Where is there's my super glue. This one is a little bit more stubborn. Let's try the, well actually let's see if we can put a knife, help break it up a little bit. I'm sure if that's what the problem is. Now I can still see. There it is. Good old super glue. Good old freight. Come on. Where's the black piece? Oop. Let me dry out the excess before it. dries on the part. So with that drying, just a few minutes. Of course I got on my finger. With that just drying in a few minutes, I will get the other piece, which is this little one. You can I can see the layer lines where it cracked. There you go. So we need three peanuts each. I kind of wobble this. So this doesn't even need prep this a little bit more. See, these holes are perfect. Guess, oh, they're probably printed like this. That would make sense. Oh, super good. All right, let's go ahead and get these in there. Cyanoacrylate. Cyanoacrylate. What's the active ingredient? Cyanoacrylate. That's why it's called CA glue, because that's hard to pronounce. All right, prepping. I have a feeling that I didn't follow instructions, and that one of the reasons why this wobbles a little bit or gets loose is because I'm missing one of these sets of supports, because I have another 4, and I might just add them because I have them. The question is, what were the instructions? That's a great question. And for number 3, I like this instructions. I like this project. It's half the reason why I enjoy 3D printing is honestly the maintenance and upgrade of my 3D printer. And so this kind of was a middle ground from building a brand new printer from scratch, using most of the complicated parts, but honestly this is going to look like a completely different printer. Probably replace the electronics in short order, but at least I've kept the spirit of the original printer for now. Because if I was building one from scratch, I'd probably do a Core XY, or grab a Core XY frame from AliExpress or Amazon, and then design the electronics and heated bed and kind of choose a little bit nicer parts for that. But I have this for now, hopefully. Hopefully it'll work again. This is going to be a tight fit. That's fascinating. This is completely different dimensions than what I have, which leads me to believe I've installed the motor mounts wrong. Because that's the only way I could have such a high offset. I love this little ruler, but it doesn't go to the edge. All this 3 centimeters. That looks like it's off by 3 centimeters. Time to refer to the old previous instructions. I don't understand. You know what? I think I'm going to call it. Oh, that's close. I think I'm going to call it here. I got some more reading to do, maybe some debugging of documentation to do. But look, we have a frame again. It almost looks like a printer. Anyway, if you watch this live, thanks for tuning in. If you're watching this later, thanks as well. If you're building this project and you have any feedback, leave them in the comments below or any suggestions. I'd love to hear from you. Anyway, talk to you soon. And let's figure out how to end the live stream while we're at it, shall we?